time for Catalog and Cocktails, your honest, no BS, non-salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd, product guy, joined by Juan Cicada. Hey, Juan.
Hey Tim, how are you doing? It's always a pleasure to be in folks' ears and people hopefully taking time off to spend a time with us and learning and chatting about data and about listening to our little cocktails and stuff. And I'm super excited to have today Lena Hall, who is our Senior Director of Developer Relations at Akamai and an AI practitioner. Lena is one of those voices that you see constantly sharing so many valuable insights when it comes to AI and agents. Got to spend time with her in Sydney and in Melbourne at the data engineering conference. And I'm like, yes, we must have Lena on the podcast. How are you doing?
Hi, folks. I'm doing great. It's so amazing to be on this podcast. I've been hearing from so many people of how excellent and fantastic the conversations here are. And it has been a while since I've seen you, Juan. So I'm very excited to catch up and talk about all things AI, data, agents, everything that's important right now.
And so much of that. But before, let's kick it off. What are we drinking, or what would you like to be drinking? and what do we want to toast for? Lena.
Well, I have this handcrafted artisanal beverage that I made myself. It's water. It's good for you, I heard. So yeah, I'm just keeping hydrated, and I should have been more prepared to actually make a fancy drink. I'm so curious what you're drinking.
What would be your your go-to?
What would I make? I am a huge fan of sweet tea. The southern sweet tea you can mix up, maybe add some lemonade to it. I feel like that's such a great balanced drink. There's never enough sugar that you can consume, right?
Oh, I'm actually the person who gets unsweetened tea because it's just that sweet tea is way too sweet for me. But
it's all about balance, right?
Tim, how about you? What are you up to right now?
So I am drinking something I kind of made up, and I'm not sure if I love it or just like it, which is that it is pineapple rum with some blackberry lemon syrup and some soda. And it's all right, but I'm not getting all the flavors, the fruit flavors, right? So an experiment today.
All right. Well, I'm also, we are recording this a little bit too early. Not super early because Tim's still having a drink. But
Juan's trying to judge me is what's happening here.
I'm actually, a little bit jet lagged, so I didn't want to have a drink right now. But I am just having one of my favorite sparkling waters. People, this is the LaCroix de Limoncello. I hear people love it. Some people hate it. I love it. But I was flying yesterday and was at the lounge, and they had their own drinks you can mix up. And I made this interesting mix, which I enjoyed it. Whiskey, a bit of Campari, and a splash of ginger ale. That was like, oh, I needed to do this again.
And I don't think I've ever had those in combination before.
No, because the whiskey Campari and vermouth is the Belvedere, but I forget what it's called. That's a drink. But anyways, there was no vermouth, so I put some ginger ale. But anyways, that's the one that I'm drinking. Well, I need to try that again. But and what are we toasting for, Lena? What do you want to toast for?
We are toasting to reliable AI. Make sure that everybody gets things that are working well and actually brings them money and profit and reliability. So that's what we're toasting for.
Love that. Cheers to reliable AI. All right, so let's kick it off. Honest, no BS. How do we put together all of the AI agents and context? I mean, everybody's talking about agents and everybody's talking about context. How does it all come together? Because you've been writing so much about showing all your experiments you're doing. So
yeah,
take it away.
Yeah, I think it's definitely an interesting area. And since we've gotten the power of LLMs, companies are trying to figure out what can we do now that we couldn't do before. So we still write deterministic code that solves specific questions. But now what we can do is we can we can widen the set of problems that can be solved with natural language. Of course, use cases like chatbots, like personalized recommendations, things that adjust on the fly. And all of that under the hood is powered by LLMs. And there's a fancy term that we have now called agents. And agents in reality is kind of like a wrapper around an LLM API that we can send requests to, that we can send to a reasoning loop that is connected to tools. Tools can be calling other agents, or they can be executing deterministic code, right? So simply, that's kind of the definition of what an agent is. And how we get from, yeah, we have an agent in our system, to we have an agent that actually does matter for our users and brings us the results that we want, that we expected. That's a kind of a different story. And that's what everybody right now is trying to figure out. We have so many different agent frameworks out there in different languages. We have people who are building agents from scratch, just kind of bootstrapping their own orchestration for how they work with LLMs. We have people thinking about creative approaches of like how to make them reliable. How do we manage context of what goes into the LLM? And does it even matter to have a longer context window? Or is it all about how we shape things that go into it? So I feel like that this craft, it is an art and science of how we get that to work properly through software engineering. Building agents is primarily writing software and managing the inputs, the outputs, how they work together in a distributed system, and how you're evaluating the impact of those results in the actual running product. So that's the very high level kind of thing to start with. I don't know if you have any thoughts from your own experience of what you've been witnessing in the community.
I think that's actually a really good setup and framing, and I think we've been seeing a lot of the same. And before weighing too much in, kind of from my side, or Juan from your side, I'm kind of curious, Lena. Like, I think some of the folks who are listening to this podcast are probably pretty decently steeped in the AI space, but then I would suspect that a good chunk also aren't as steeped in it. And I'm curious from your perspective, Lena. Like, if you had to catch somebody up in like a minute on kind of like AI right now, right? You talked about agents and some of that piece. Like, are a lot of people, are you seeing a lot of people building like custom agents? Are you seeing a lot of people using things like OpenAI and Copilot and stuff like that, and really doing it more within the framework of one of those types of things?
Yeah.
Obviously now there's Gen AI and agentic features being added to application platforms and data platforms. How do you see kind of quickly the landscape of things right now, just to kind of catch our listeners up?
Yeah, I love that we're having this question, because if we just take the word agent, and I think Juan is gonna love this, but like the meaning of the word agent means different things to different people from different backgrounds. So I think that when I say agents, it's an umbrella. We have these coding agents, so like Claude Code, VS Code with Copilot. We have agents that we write, that we integrate into products. That's a piece of software that we write that sends requests to an external API. I think people are doing both. You can write software that doesn't consume an LLM, but you wrote this software using an AI agent, like within your cursor IDE, right? That's an AI agent. Or you could write code manually that is creating an agent within your product that is adding agentic functionality into your application, right? So these two things are completely different they have completely different set of problems and issues around them, and the workflow of how we approach them. And both are super relevant, I think, right now. I am seeing almost every developer that I talk to, if they can, they use AI coding agents in their workflow. Even if there's some restrictions at the workplace, they're still experimenting and learning how they can be more effective with that. On the flip side, not everyone's job right now is around building like AI agents integrated into the product, but there is an increasing set of engineers that I talk to and teams that I talk to that who are tasked to integrate AI into their business. So I see both things. I think the first AI agent coding is probably more prevalent in the like developer community than building agentic functionalities into existing products and systems.
What I appreciated is when you gave your definition of an agent, right? You just said that it's a wrapper over LLMs, and I think that's how people are seeing this today, and that's what makes it so easy to start. Um, how do you start? So this is what let's dive into like what are the easy ways to go start? When do things get more complex? How do you know that you should start switching? Because you've done all these experiments, and by the way, like people listening, like you should just really follow her videos and the content she puts on LinkedIn, because it really steps through this stuff very, very nicely.
Yeah. So how do you actually start with your first agents? So are we talking about coding agents or are we talking about building agents?
Let's talk about building agents, because I think
Building agents.
yeah.
Yeah, great. So I think my advice would depend on like who I am talking to. If this is a beginner engineer or somebody who is like making their first step in technology, it would be different than talking to someone who's super experienced. So two approaches. One is pick one out of the three options that you have. Agent builder, like a visual style app that lets you just write what you want to build, and it creates an agent for you behind the scenes, and you get that front end experience of I provided my idea, my intent, and I'm getting something that's working. That could be an agent. So one thing. The second approach is pick an agent framework. And the choice here is vast, but I would say pick one of the most popular agent frameworks just to try out. LangChain, LangGraph, Crew AI, ADK, things like that. Pydantic AI, amazing. So I think just pick one thing to start with, and learn from the docs of here's how you actually create an agent concept within your programming language with that framework. And that will give you an idea of doing similar things in other programming languages with other frameworks. But I think for more experienced professionals, it would be interesting to just kind of write an agent from scratch to see like how you actually manage all the things from top to bottom. So just use an API, use OpenAI API or Anthropic API or whatever other your favorite LLM is, and play around with different parameters that you can tune. So there is temperature, there is sometimes thinking in GPT. Figure out how you're managing the prompting back and forth, the history, when you connect it to different tools, how it works. Is it decreasing or increasing performance of your output? So by using the from scratch approach, you can really learn all the bullets and pieces of what actually happens behind the scenes of all of these agent frameworks. And each agent framework is just picking a philosophy from which they are attempting to work with that API. Some of them provide very, very useful abstractions for like sequential processing versus parallelizing execution of agents, multiple agents coordinating between each other. Once you get deeper into, like, you tried your first agent or you built your first agent from scratch, you start noticing things in the community that keep coming up. Like right now, there is a new repo that popped up a few days ago called MCP Agent Mail. That's a way to get your agents to talk to each other. It's like send emails to each other and coordinate on tasks. So there's so many interesting things that keep popping up. But first step is always to take the first step and try something once to give you an idea based on your level of experience and interest of how that works. And I think that would be something that will give you more questions to ask if you are curious enough to go down that rabbit hole.
I've heard this approach mentioned by a couple of folks, and I'm glad to hear you kind of reinforce it, which is to kind of play, like try it out, experiment. You mentioned like tweak the temperature, tweak the settings, like and I imagine now, right, with things like MCP. It's very easy to try to feed agents different tools and see kind of, does it how does it react, right? So it is I like this idea of kind of playing around. And for the developers that I've heard, and even non-developers, right, people who are doing more visual approaches and things like that, I've heard that they're and I wish I had a little more time to play around myself. I want to get more hands on. They're having a lot of actually fun building AI agents because it's very interactive, it's very iterative. And even coding agents, I know we were talking more about building agents, can be a very fun experience too, because you're kind of giving it some instructions. It's like having like this incredibly smart intern and letting them kind of work in the background while you go get your cup of coffee or whatever.
Yeah, and I think that in the coding using AI agents, that's the most fun area where the most common thing that I'm hearing is if somebody's a backend engineer and they are using it, now they're a front-end engineer too, because they can just delegate, make a really pretty user interface and interactive experiences that kind of enable them to focus on the things that they're really good at, like architecting how things should be, designing the flow, paying attention a lot to the specification and like data modeling, instead of focusing on the little things that usually take a lot of time.
So we started off the conversation about like context and AI agents, and we kind of appreciate the framework of the different approaches of thinking about this. So how are you seeing the context? Like this right now is a popular thing, context, semantics, knowledge graphs, all this stuff. But how are you seeing this for everybody you talk to and you're working with? How do they start off with, and what are your recommendations here?
Yeah, so I think we can also split that discussion into the coding agents context,
Okay.
context engineering, and then context for agents within a product. For coding agents, when you spend a lot of time prompting and you spend a lot of time in your IDE or in your CLI, kind of asking it to work on a project, you quickly notice that after a while, it doesn't get better. Like it gets worse. The quality of the outputs, and it frequently starts kind of contradicting itself. So the underlying issue is that the more context we have, it doesn't always mean the better the result is going to be. Earlier in the journey with LLMs, I think we were all hoping that once we're going to have such a large context window, we're going to be able to solve all the problems that we have now. But now we realize that at around 1 or 200,000 tokens, we get this experience that isn't improving. So we need to restart the session, or we need to summarize the conversation and basically kill the current agent and start over. And from here, we are faced with a couple of choices or interesting problems to solve. Like, how do we maintain the progress, like where we're at now? How do we compress context? How do we let the next agent, the next session, know what we've already tried and where to kind of start from? What are the approaches that we can use to maybe parallelize the work across multiple sub-agents so that each agent has smaller context, but also is more focused on the specific things that we need solved? And from here, there is a couple of like practical things that we can do. The standard approach is you open your coding editor and you just start chatting with your copilot. That will not scale in the long run. So what works better is if you write a detailed spec of what you need, and you don't always have to write it from scratch by yourself. You can always brainstorm it with another LLM or with the same LLM. But the key is that you, as a human, you have the control over your intent, and you're responsible for serializing that intent as clearly as possible for the LLM to take it and transform it into something practical. So a lot of people, what they try to do is they generate a spec and they're like, okay, kind of looks good, and then they're surprised that the implementation actually isn't great because there were some misses in that spec. And the LLM will follow your spec. It's just you have to be sure that that's exactly what you want to accomplish. So my advice would be to, if for senior engineers, is to spend probably 80% of your time thinking and focusing on your plan and your specification, and also working with an LLM later to split that into manageable tasks that you can track and see, like, is this actually, has this completed? Did it just say that it's completed, or do you actually have all the functionality that you need? It's always fun what LLMs come up with when they want to make you happy. Like, they want to tell you that it's working now, all the tests are passing, and they're just hard coding the result there that you want to see.
So before we go, so this is great. And then before we go to the context for the building agents, so one thing I think you posted about this recently was you shouldn't just the code the coding agent will generate that code, and then it's not about then always fixing that code afterwards. It's
Oh
probably
yeah.
no, then probably what the spec that you wrote originally, actually that should be improved. So how much of this should be, like you said, 80% of your time like spending on top up front? Is this really the intention, is that the goal is to do all the amount of work up front such that the result is always going to be as close as correct, if not versus doing any type of correcting work afterwards?
Yeah, I think this is like a new skill or a learning curve. I would say this is not natural to most engineers right now. We're just so used to fixing the code.
Yeah.
And until you get a feel for it, get a feel for what it actually feels like when you fix your spec and it starts generating things more correctly, you probably will not feel comfortable doing that as your default workflow. But I think, for me at least, and for a few people that I know and love to collaborate with, that's been the approach that works, where the cost of the time that you spend fixing something in the specification is much lower than spending 2-3 hours trying to fix all the derived errors that span from trying to fix the artifact. And one of the examples that I really like from the talk by Dex Horthy on the advanced context engineering, he gave an analogy where, like when we write code in Java, we get a compiled artifact. We're not going to go there and fix the compiled artifact. We're going to fix our code in Java. So
that's a great analogy. I mean, at the end of the day, we're just at a higher level abstraction, right? So we're like the code that's generated by the LLM, which is code which you can read. I mean, that's already kind of low level, that you want to keep your specifications at a higher level, cleaner, more exact. And I think, in a way, we say that these agents are helping us to be more productive when writing code, but at the same time, I'd argue that maybe it's going to challenge the people who just know how to write code versus the people who are actually problem solvers, and they're thinking about the algorithms. Like, go back to like give me the instructions to create a peanut butter and jelly sandwich, right? You go through, you give those instructions. You've seen all these like videos when they tell kids and stuff,
yes,
right?
yeah.
Well, you got to be more precise on these things, right? Really forces you to think about the problem up front versus like, I'll just throw shit at the wall and see what sticks, and then I'll fix it later.
Yeah, it completely breaks the flow on like how software engineers used to work. When you kind of think through the problem and code in parallel, you might change your spec that you haven't documented while you're writing the code. Your brain works differently, and now you have to front load thinking about all the edge cases, thinking about all the trade-offs, and multitasking as well. Like when you're reviewing the code that has been written so fast, you barely got time to go get your coffee or tea and come back, and now you have to get back to the next stage. Like it accelerates the speed of like thinking, and how you it challenges us, right? It makes it challenging.
So now let's talk about context when it comes to building agents.
Yeah, so that's where it gets tricky, because when you work with an LLM inside your coding agent, you can tell it, yeah, this plan doesn't look good. Let's fix the plan and evolve from there. When your LLM is embedded basically inside an agent in a working application, it will get input from a chatbot, from a user. You don't know exactly what that input is going to be, and then it's going to perform some set of actions. It will have some tools available, but we don't have that visibility um, ahead of time of what is the sequence of tools that it's going to call, or how exactly is it going to reason about that issue. So one thing that has been helpful to a lot of people building this in production is doing evals on the LLM with the real user data, comparing the real output of an LLM or real action of an LLM to something that would be an expected action. So, for example, if you get a prompt to a customer support chatbot and it responded in the wrong voice or it gave a wrong recommendation, then a domain expert would flag this, saying this didn't pass. And we need to rework the prompt in the future to avoid this type of case. But this is still kind of a different mindset. We can't influence this in the middle, in flight. We can fix the prompt, but we're still kind of not, we don't guarantee the reliability of anything that comes back from an LLM. So my advice here is that we have to be really conscious about the deterministic versus non-deterministic steps in our business workflow. If you can afford a mistake, even a small mistake, yeah, you can definitely use an LLM. You can figure out what part of business problem you can solve with it by still bringing you value. If you cannot afford that, my recommendation is to do as much deterministic as possible around your business problem. And where it gets interesting is we have a lot of interest from large businesses to plug in the entirety of their data, like their databases, their APIs, and just kind of plug it into the LLM so that it starts accessing and reading and managing and figuring things out. But we're starting to run into the same issue that we have with the AI coding agents, where if you plug in too many tools, it gets confused. If you try to front load too much of the context, it doesn't necessarily always know which way to go. So that stays kind of in the same area of issues as with the coding agents. There were some interesting innovations that I've seen working in a few businesses with using an LLM to plan the query and then generating a deterministic artifact to execute on it, which is a different mindset than most people are using right now for building AI products. So instead of taking that customer support question and just telling LLM, go run with it and give me the result, you ask an LLM to use that business context to generate deterministic code that would solve the problem. And to make that happen, you kind of need to build a semantic graph of all of your underlying business data and self-improve it over time from those interactions with users and domain experts to make it precise and reliable. So that's very complex. We don't have a ready-to-go product or tool that does that. Some people who have seen success with this, they are building it from scratch, and it's a large investment, but that's another unique approach that I've seen that has been working quite well.
Interesting. Well, I think, well, first of all, it's interesting how much working with both the coding agents and the build agents feels like you've got like a team of people, and you're trying to like be like, do more of this, do less of this, and just how much it feels like management more than than just robots magically doing the right thing. So that's just a kind of a fun observation of how things are working so far. But then I think this kind of ties now into a second conversation, especially with some of what you said at the end there with the interesting approaches that you're seeing and how people are trying to manage context. In your opinion, what does it mean to achieve reliable AI? Like, what is reliable AI? And, do you see certain patterns that people are needing to do to you mentioned like a spec, for example, like, are there different ways that people are trying to manage this context so that you achieve reliability, certain architectures and things?
I think. Oh, sorry about that.
Oh, no
Kids.
worries.
Real world life
I
situation,
know.
folks. This is it. No worries.
Yes. So to achieve reliable AI, I think this is a question to you as the owner of the problem that you're trying to solve. Like, what does success look like? And if you are able to answer this question for yourself, then you would use the same answer to what does reliable AI mean to you. So AI is just a tool in how we can solve it. You can solve a lot of problems without using AI. So the way that I've seen people succeed with that is understanding the confidence levels in where a mistake can happen. Um, if if you're trying to increase productivity, there's a use case around like making your work faster for, like, let's say medical professionals or accountants or something in another business domain. The worst thing that can happen is you don't increase your productivity. So maybe you're not losing anything significant. You just don't get a gain. So that's one of the things where you can risk it and you can embrace an approach with AI that will, in 99% of the cases, bring you the ROI that you expect. And maybe in the couple of those percents, you will just have to work the way that you used to work before. So that's one framework. Just think about what the risk is for the use case that you're trying to adopt. And then how can we actually get there is experiment with an isolated set of scenarios. So select top 1 or top 3 things that you want to bring AI into, and don't focus on the risky ones at first, but see if your expectation aligns with reality through using evaluations. So once you have your versioned prompts and or specs that you are using, you will be able to see if this version gives you a good enough result to move forward or not. But you have to have domain experts helping you with this. If you're a business owner, you may be the domain expert, or you may have a dedicated team who owns that product and is a subject matter expert. From there, if you're unhappy with the results, you have to rethink the approach, and you have to think through how can you improve the context that is going into an LLM. That may be simple as much as curating or reducing more the list of tools that you have available for it. Maybe you need to build more specific, more focused agents that have less room for context overflow or confusion. Maybe that does mean investing heavily into your data infrastructure and building that semantic core layer that will then allow your LLM in product to understand what things mean. If somebody is a customer who is trying to buy something from a company, it's a different than a customer that is in some other table in a database. You have 2 names of the column, but they mean different things. You need an LLM to be able to make sense of those things, and that's impossible without building out that graph-based semantic database layer, context-aware layer that improves the comprehension of how LLM works with your inputs and requests.
I truly appreciate you're stating in a way some like quote unquote the obvious, but again, over and over again we have to state the obvious over and over again, right? Because this stuff gets lost. I mean, at the end of the day, it's like you got to start with your use case, and if you start with your use case, you remember that all of these are just tools, and then you can solve that problem with so many different tools, AI being one of them. So you actually know what the baseline is, you know what good looks like, what success looks like. So that's the great thing that you're reminding us. And again, very use case driven.
Yeah, and just before we move to lightning here, I think what's interesting, and Lena, your observations and your recommendations, I think, go really well with this. It feels like as an industry, we're really starting to understand that at least not in the near term, right? Maybe in longer term we'll figure this out, but in the near term, we're not creating like this one Oracle AI that's just like knows everything and can do everything, right? We're finding a lot of value in specialization of agents, specialization of context, specialization of even LLMs, right? I hear a lot of people talking about small language models instead of just large language models. Why do you need to teach it on the whole internet if you just need it to generate code, for example, right?
Yeah.
So I find this specialization aspect very, very interesting.
This is typically like when people start writing code for the first time, they write everything one gigantic function, when people are modularizing it, right? I mean, then you have like things like microservices and stuff. Like we're building all this stuff, and I think this is why for me it's always still computer science, because we're going through the same phenomenon of computation that we're going over and over again, right? This is just a higher level abstraction. We're building things. You can solve the problem. You're breaking it down to smaller pieces. And then you realize that if this is not working, you got to test. You got to inputs and outputs. I can break this down. I find this fascinating. So.
Can I just quickly jump in on something that Tim said? So the small models, I think that's a really great point as well, because we're not only deciding like what we're building, we're also deciding where we put the agents that we're building. And big models, they just don't fit everywhere, right? We can do a lot with small specialized models, especially if we need super low latency, super high performance, cost effective applications. Like we can put them at the edge, right? So we can distribute them globally, and there are so many interesting use cases with things like real-time physical AI, where the robot will not wait 2,000 milliseconds for the inference loop to complete. They need something right now. So I think that's an area to watch with the small LLMs.
Specialization of agents and context can result in faster performance too, because now you're not, the inference time and everything. Wow. Yeah.
All right. Lightning round. Quick yes to no. Let's do this. In the past, we talked a lot about prompt engineering as that new role. That seems to have died down. Is agent engineering kind of a next thing, or what is the next role coming in around here?
There is so many engineering terms right now. There is vibe engineering, there is context engineering. I haven't seen agent engineering like applied widely yet, but I think we're going to have a new engineering thing tomorrow that we're all going to try out. So, but to me, I really like the term context engineering because it goes beyond the prompt and takes into account everything around it.
Yeah,
all right.
I like that phrase as well. All right, second lightning round question. Does an AI agent have to be a Gen AI agent to be an AI agent?
Oh, this is so specific. Well, we can go back to the transformer paper, attention is all you need, and like figure out if generative AI, is it synonymous with transformers and like the way that the current LLMs are built. Most of the agents that come to my mind are like using an LLM based on something like transformers behind the scenes. So it kind of implies generative AI, but that's an interesting question. I would be curious to hear from the audience. Maybe you comment and tell us what you think here.
Yeah, that's a good thing for the broader data and AI community to comment on. What do you think about that? And I like it when the definition's a little more narrow, right? If we say it has to involve Gen AI, because if it doesn't have to, then I don't know. A lot of people are kind of overusing the word agent now, and now like even a rules-based system is all agents. It's all agents, right? So yeah.
Yeah.
Next question. Are you seeing an increased interest in using knowledge graphs as a way of managing the context for AI agents?
Absolutely. Yes. 100%.
All right.
Awesome.
Final question.
And then final lightning round question, then we'll do our takeaways. You mentioned that for coding agents, it helps for them to work off a spec. It helps for them to have subtasks, right? We talked a little bit about specialization. Are we headed towards a world that, if we look at the next phase, the next iteration, where, we went from LLMs to agents, and are we going from agents now to like agent swarms or agent meshes or agent clusters? I don't even know what you would call that. Like, is that kind of the next thing? Because you have like a management agent that writes the spec, and you have the coding agent that executes the spec, and you have a testing agent. Like, is that kind of where we're headed?
I think we're seeing some of that right now. We're kind of splitting the responsibilities of the agents for some things, but I also see a very like opposite point of view from some people in the industry where they are holding out on the whole agent and agent framework philosophy because they believe that the models will get so powerful that we will not need half the functionality of the agents as we have them now, because they'll be able to just figure things out better in their reasoning. So they'll get smarter, and we will not need so much orchestration and management of those agents. So I feel like there's different versions of what it might be. But to me, whenever you have an agent, you want to integrate this into your business and you want to get profit from it, you have to think about, is it going to be reliably bringing you the result that you want? And right now, all I know is that agent engineering is software engineering. We have an unreliable component within our application, and we have to manage it somehow. So, and what will happen next, we will see. But for now, I feel like it's not a very clear path forward.
All right. Takeaway time. Tim, take us away. Takeaways.
All right. I'll try to keep this tight. We started off with, AI agents and context. Like, what's the honest no BS around that? And you started off by saying, hey, there are certain things that we can do now that we couldn't do before, right? Conversational experiences, personalized recommendations, things that adjust on the fly. All of this, especially today, involves most often agents. Those agents are a wrapper around an LLM API that can send requests to different services. You can put it in a reasoning loop. It can call other agents. It can have deterministic code that's part of it, and it's taking action, right? And so I actually felt that was a very practical definition around agents and very useful, I think, for folks who sometimes hear more pie in the sky kind of definitions for things. And you said that there's kind of different kinds of agents, and it's all a bit of a mix of art and science. There's coding agents, which are more, your VS Code, your GitHub Copilot, and things like that, which are helping to program. You've got building agents into products, which is more, kind of code calling APIs and these loops and things like that that are more around interacting with products and data services. People are doing both, and they both have similar problems, but they also have different problems as well. And we started off by saying, okay, well, if you want to do these, how do you make them effective and reliable? What are people kind of doing with these different kinds of agents? And starting with, building agents, which was the second set of agents we talked about. You've got like agent builders, which are more of a visual style. You've got agent frameworks, which is kind of, Lang chain and all of these different things that you can build agents with. And in general, kind of the biggest feedback around them is experiment, play, try them out. Like, this is the best way to kind of learn how to interact with agents and build agent products. With that, Juan, over to you.
Yeah. So when we get into context, it's great that we were separating this coding and the building agents. So when it comes to coded agents, when you spend a lot of time prompting, after a while, it starts to get worse, right? That means that the more context we have, it doesn't result always in just get better results. So instead, this is really about writing a coding spec that tells your agents your intent, and the coding agent does that. But your spec isn't always right. So what you really need to think about is like spending most of your time thinking about your spec and split into manageable tasks and what is done by each piece, versus instead of fixing that code that was generated, right? So you want to try to manage a spec and manage all these subtasks. And when you get good at fixing the specs, it's much more faster than fixing the outputs. And then when it comes to the building agents, a lot of these inputs are coming from chatbots, from people that you don't even know what those actions are, but you don't have a visibility all the sequences of tools are going to be called and how it's going to reason around this. So you need to really start doing evaluations with real users' data and inputs, right? And compare the outputs of the LLM to what you expect the answer to be. So if you can't afford a single mistake, then probably you shouldn't be leaning on LLMs, and you need to lean on the more deterministic approaches, because if you start to plug in so many tools, this is going to get more confused. And then we kind of closed with the whole reliable AI. And at the end of the day, as the owner of the problem that you're trying to solve, like, you know what success looks like. And remember, AI is just a tool, and you can be already solving that problem with other tools too. But so you have that baseline. And so you understand where mistakes can happen and what those mistakes could be and what those risks are. So you need to understand the risks for those use cases. So select by your top 1, 2, or 3 different things that you want to bring AI into. Don't focus on the risky ones, and evaluate to see if the results does fit your reality. And for this, you will need to have domain experts around that. And if you're unhappy with the results, that's when you improve with the context. And that's where, especially when you're bringing extra data, you're investing into data semantic infrastructure. And that's why a semantic knowledge graph is going to be critical for that. And we talked a little quickly for small agents, small models. And so we can do a lot with small specialized models, especially when you need low latency, put them on the edge. For example, real-time physical AI needs that.
That's a great summary.
All right. Anything we missed?
No, I think this is great.
All right. Well, back to you. Thank you so much. 3 questions. What's your advice? Who should invite next? And what resources do you follow?
My advice, I think, don't listen to anyone. Learn software engineering. Become good at architecture. Become good at data modeling. For managers, make sure you don't lose your most subject matter expert people who have the deepest skills in computer science, and also the understanding of trade-offs. Those are the people that you will need to rely on to make sure that your AI actually works. So who should you invite next? I would say Simon Willison. If you get him, that would be amazing. He has an amazing blog, which is actually one of the resources that I look into a lot. And where do I get information? I just mainly look through social media, LinkedIn. A lot of interesting small things pop up earlier than they're captured anywhere else, and just gets on the radar that way. I feel like the recommendations there sometimes do work.
Lena,
really great advice. And I love that you put vibe coding on notice a little bit.
thank you so much for this very practical discussion. I mean, I think this is an episode people listen through, and they will people are just starting, they will be able to kind of see the bigger picture, and you've given them a path of where to go next. Thank you so much.
Thank you. That was
Cheers,
great.
Lena.
Cheers.
Cheers.